The Extended Range Cannon Artillery (ERCA) program has broken the record for firing highest velocity. While shooting far distances is desirable and part of the Army's modernization strategy, firing at a high velocity is also a vital element to eliminating threats through multi-domain transformation, in this case, increasing the range, speed, and convergence of cutting-edge technologies. In general, artillery systems can be more cost-efficient compared to using missiles and rockets. An artillery round can potentially complete the same mission at a fraction of the cost. Leading up to gun tests, the team used various ballistic computer simulations to project the outcome based on different configurations. These models help during the developmental stage and also provide insight during test fires. To develop a projectile for these high velocities, the projectile engineering team used a finite element analysis model. The igniter, which is part of the ignition system, is behind the propelling charge, which sits behind the projectile. The force of the propellant gas on the projectile is what causes the round to shoot out of the cannon, when optimized breakthroughs in projectile velocity are achieved. During test fires, the YPG team collects data such as high-speed video, pressure, and muzzle velocity. The projectile team monitors the projectiles, then compares the data collected at the test site against the data of the model. Since the charge is inside the gun chamber when fired and unable to be observed visually, the team developed a ballistic simulator, BSIM, to aid propulsion development and emplaced it at YPG. The BSIM tube is transparent and bursts at a low pressure, but the few milliseconds of video data before it bursts is critical to the design of the propelling charge.